Hello everyone, welcome to Flip-Flop Data. Today I will speak about how to interpret a linear regression model result so that these give you better insights and business benefits. I will consider a problem definition and a dataset attached with it. Then I will try to fit a linear regression model to analyze and interpret the results. So before I start, I assume you all are familiar with the basics of linear regression, as I will not cover basics here. But in case anybody wants to learn or brush up their basics, there is another video wherein I have explained basics in detail. Also, there will be a second part to this video series wherein I will show you how you can calculate Fstatistic, residual standard error, R-square and adjusted R-square manually so that you can understand in and out of it. So let's discuss the topic map. First, I will give you a short introduction to linear regression, then problem discussion. Third will be analysis and interpretation, and then comes conclusion. So what is linear regression? Linear regression are the part of family of supervised learning algorithms. In particular, these models are useful tool for predicting a quantitative response. They form a part of inferential statistics, since analysis tends to infer properties of an underlying distribution, that is the population. It is a linear approach to modeling where relationship between a response variable, that is the dependent variable, and one or more explanatory variables, that is independent variables, is modeled. So it strongly considers a linear relationship between dependent and independent variables. So consequently, the importance of having a good understanding of linear regression cannot be overlooked. So let us take up a case of hotel reviews posted wherein the travelers rate each and every facilities of the hotel, and then we'll try to analyze overall review rating based on the fitted linear regression model. So coming to hotel dataset. The hotel review dataset consists of 11 features and 500 observations. So you can go through the description of these datasets to just find out what each one is for. So now let's move on to the modeling part. So these are some of the salient points which needs to be given a read before we jump into the modeling. I will show you how we can fit a linear regression model in the RStudio. So coming to RStudio. First and foremost, what we do over here is we read hotel review data, which is a CSV file, into the data frame hotel review. So let's execute this. So what we get over here is the description of the data set and the summary. So observing the description and summary of this data shows us 10 independent variables and 1 dependent variable with clear depiction of minimum, first quartile, median, mean, third quartile, and maximum value for each variable. Then next step is converting all the integer variables depicting ratings and the review days after checkout into normalized form. So we do it over here. So normalized form is needed because sometimes their means and standard deviations are different, which might affect the result. Hence, by normalizing, we ensure that they are compatible, have almost similar range and values, which gives us accurate results. Then next is all the categorical variables are converted into factors and leveled so that dummy variables can be created. Let me execute this. So this is basically one of the advantage of converting into factor variables. It makes very easy to create dummy variables. And R is smart enough to create dummy variables considering one level as reference variable. That happens automatically, and it is based on alphabetical order of the levels within the categorical variables. For example, in our case, if we see traveler type, it depicts 5 levels, that is business, couple, families, friends, and solo. So hence, based on alphabetical order, R considers business as the reference variable, based on which other dummy variables will be evaluated, and 4 dummy variables are created, leaving the reference variable business. So in case you are interested in changing the alphabetical order sequence, then please set reference variable of your choice and do the re-leveling. So mind it, for 5 levels, only 4 dummy variables are created to avoid multi-collinearity issue. So let's see the description of scaled dataset. So this is here. So now once all these steps are done, we will develop or we will fit basically a linear regression model over here. So this is our LM function. We run it and we create our model. Let's see the summary of this model. So it is here. So before I proceed further, let me tell you all, I will not cover any feature engineering in this video. Also the multi-collinearity, autocorrelation, normality, heteroscedasticity, outliers, leverage, and influence terms for linear regression will not be covered here. So I am in the process of creating another video to elaborate on all these terms. But here I will show you how linear regression fitted model results can be interpreted. So let me go back to my slide. So this is my same result which I have captured from RStudio and I have put it in my slide. So let us now interpret each of these parameters. First and foremost is to look at Fstatistic, which is 36.44 over here. It is much larger than 1, which is very much acceptable. For Fstatistic, anything which is very much greater than 1 is acceptable. Going further in the second part of the video, I will show you how you can calculate Fstatistic manually. Second is degrees of freedom, which is 478 over here. So how degrees of freedom is calculated? It is total number of observations minus number of independent variables minus 1. So our observations over here is 500. We have total 500 rows in our data set. And number of parameters, that is number of independent variables, are 21 over here. If you count this will give you total 21 independent variables. So 500 minus 21 minus 1 gives us 478 degrees of freedom. Then coming to adjusted R square, which is 0.5986. So in marketing context, it is good enough for cross-sectional data. So here we are using cross-sectional data. So what is meant by cross-sectional data? Cross-sectional data is nothing but used to describe what is happening at the present moment, and this is frequently used to determine the prevailing characteristics in a population at a certain point in time. Hence, our fitted model is totally acceptable considering small data set of 500 observations. And if we want to increase acceptance further and make our fitted model more accurate, we need to have much larger data set to probe into. So now coming to our independent variables. So first, let us see, does variables like rating location, rating rooms, service, sleep quality, and cleanliness affect our regression results? So if you see closely, yes, all of these variables are significant since p-value for all these are much lesser than 0.05. So why 0.05? Because I have considered 95% as my confidence interval, which gives p-value as cutoff as 0.05. So anything less than 0.05 is significant for us. So if you observe very closely, out of these 5 variables, location, rooms, and cleanliness are the most significant predictors. Why? Because all 3 of them have same p-value. You are able to see location, rooms, cleanliness. And this p-value is the lowest among all the other 5 ratings variables. But we have to find out which one is most significant out of these 3, in the sense out of location, rooms, and cleanliness. So we will look at t-value over here. So out of these 3 variables, cleanliness has highest t-value. Coming to cleanliness. So this has highest t-value, which is 15.796. And location is little lesser than that, 13.172. Then rooms is 10.086. So hence cleanliness is considered to be most significant because it has the highest t-value. So higher the t-value, the greater the confidence we have in the coefficient as a predictor. How is t-value computed? T-value is computed as estimate divided by standard error. This estimate, when you divide by standard error, it gives you t-value. Now looking at next p-value. Sleep quality is the 4th significant variable. And then comes our service as fifth. So sleep quality. Sleep quality, if you see, it has a p-value which is very less as compared to 0.05, but little bit more than the other three variables, location, rooms, and cleanliness. So it lies fourth in the ranking. Then fifth is service, considered according to the p-value. So now comes how do we interpret the estimates or the coefficients. For example, consider rating location, which is positively associated with overall review rating. We can see the estimate as positive. What this means is that overall review rating increases by 0.38399 for every proportional unit increase in rating location. So I will repeat again. This means overall review rating increases by 0.38399 for every proportional unit increase in rating location. So now moving on to next interpretation. So does dummy variables like traveler type couples, traveler type families, traveler type friends, and traveler type solo affect the results? Again, if you observe very carefully, you will find that the traveler friends is totally insignificant and traveler couple is also very little significant. Hence, we can drop these two from our interpretation. But the traveler type family, if you see, it is significant as p-value is less than 0.05. And it is negatively associated with the overall review rating. Negatively associated. What does this mean? So this means that if traveler is a family compared to business traveler, since traveler type business is our reference variable. So traveler compared to business traveler, they tend to rate 0.68472. This is 0.68472 proportion lesser than the business traveler. I will repeat again. So if traveler is a family compared to business traveler, they tend to rate 0.68472 proportion lesser than the business traveler. I hope this is clear to you all. So this also suggests us that if the traveler type is a family, then they have the lowest satisfaction level of the lot, and the hotel has to pamper them more in one way or the other to gain their attention. So marketers can focus on devising such strategies. So now coming to traveler type solo. It is significant as p-value is less than 0.05 and positively associated with overall review rating. This means that if the traveler is solo compared to business traveler, then they tend to rate 0.86007 proportion more than the business traveler. So this also suggests us that solo travelers are the most satisfied of the lot, and hotel needs to maintain such relationships and continue offering them the same facilities throughout. Then moving on to next. Does variables like review posted after checkout days and month of visit affect the results? So again, observing very closely, we find out that review posted after checkout days is significant and it is positively associated with overall review rating. That is with 1 unit here is day. 1 unit increase in review posted after checkout days, the overall review rating increases by 0.16657. So this suggests as more number of days after checkout from the hotel elapses, the traveler tends to give higher review rating. So now coming to month of visit. It appears that month of visit December is the only significant month and is negatively associated with the overall review rating. So this again means that if the traveler is visiting hotel in the month of December compared to April, they tend to rate 0.30271 proportional unit lesser than April. Why April? Because April is our reference variable. This conveys us that there may be crowd or other unidentified reasons which hotel is not able to maintain its usual facilities and standards during peak times, and hence the travelers visiting in December seems to be less satisfied than the travelers visiting in April. So hence hotel has to look into how they can allure travelers during this time to gain their attention and satisfaction. So this is the RStudio code which I have captured as a screenshot for you people to go through. Then coming to the final conclusion. So this way entire analysis can be carried out for interpreting variables. Now summing up the salient business interpretation for hotel, how is it? So travelers are most sensitive to cleanliness within hotel, then the location and then the rooms. If customer is traveling with family, they have the lowest satisfaction level and they tend to rate lower. Third is solo travelers are the most satisfied of the lot. As more and more number of days after checkout from the hotel elapses, traveler tends to give higher review ratings. And travelers visiting in the month of December is less satisfied than travelers visiting in rest of the months. So this is the conclusion, and based on this, the hotels actually can benefit with such type of business insights and they can devise their strategy accordingly to gain revenue and to allure more and more of customers. So with this, I conclude part 1 of this video series. In the second part, I will show you another bite of the result, that how we can calculate Fstatistic, residual standard error, R-square and the adjusted R-square manually. So if you have any queries, please put it into the comment section for me to answer. And please reach out to me if you need complete dataset along with code. So let's meet in the next video. Till then, good day to you all. Continue watching my videos. Thank you. Don't forget to subscribe.